Okay, my last video got cut off for whatever strange reason the last minute did, so I wanted to kind of just go through this last problem here in section 8.3 that we were looking at. It was on page 550, problem 44, and so here's that problem again. An airplane flies due north from Fort Myers, Sarasota, to Sarasota, a distance of 150 miles, and then turns through an angle of 50 degrees and then flies to Orlando, a distance of 100 miles. So they give you a picture. The plane is starting up from Fort Myers, going to go 150 miles, turn, make a 50-degree angle, and then fly towards to Orlando, which is another 100 miles. Okay, and then in part A of this, it says, where are we at here? Part A. How far is it directly from Fort Myers to Orlando? Okay, so if we're going to make a direct shot, I'm calling that side A, miles, and I've got this picture set up. And of course, if the plane were going to continue to fly straight north, you'd have a 180-degree angle, and so knowing that this angle is 50 degrees means that the angle inside the triangle is going to be 130 degrees. Now, in this triangle, I don't have an angle and its opposite side known, and so I would want to use the law of cosines in order to get side A here. So I've got that set up, the equation for the law of cosines. In this problem, B is 150, C is 100, and alpha would be 130 degrees. So I've plugged in the numbers into my formula here for the law of cosines. Simplify, you take the square root of both sides. Of course, A can't be a negative, so I don't have to worry about the plus minus there. But then if you go to the calculator and punch that in, I can do that real quick. So it's the square root of 32,500 minus 30,000 times cosine of 130 degrees, and okay, 227.6 is what I'm getting there for that that direct distance then. Okay, now in part, so that's the answer to part A. Part B says, what bearing should the pilot use to fly directly from Fort Myers to Orlando? Okay, in other words, if the plane is starting off straight north, what angle does it need to shift in order to fly directly to Orlando rather than going north and then east? So we need to. I've labeled that angle gamma, and again I'm using the law of cosines here, and so here's my my equation there. And A, I've determined, is 227.6. B is 150. And C is 100. Okay, so I've plugged in the numbers there. I've also set this up so that I've solved for cosine gamma. And plugged in the A, B, and C values, and then I take cosine inverse of both sides. Cosine inverse, just check that here, cosine inverse of 64,301.76 divided by 68,280 is 19.7 then if you go nearest one digit. Okay, and of course that's a degree measure, so good idea to indicate the direction also. If they're starting north, you're going to have to shift 19.7 degrees northeast then to have that direct shot. Okay, the homework in that section was on page 550. We'll actually go ahead and cover section 8.4. 8.4 is not going to take very long at all. Area of a triangle. 8.4 is the last section in chapter 8, by the way. So we all know the area of a triangle, right? It's 1/2 base times height. But in this section, we're going to look at some alternate forms of area of a triangle. Okay. Suppose that you have a triangle where you know two of the sides and then the angle between them. So like in this picture here, suppose that I don't know the height, but I know A, B, and gamma. Well, in this triangle, I've also created a right triangle, okay? And sine of gamma would be opposite over hypotenuse. And so again, I don't know the height. But if I were to solve this equation then for the height would be A times sine gamma, which I know A and gamma. So when I use the formula 1/2 base times height, the base is B, and where I see the height, I would just simply replace that with A times sine gamma. Okay, so 1/2 AB times sine gamma would be the way to get the area of the triangle then. So here's an example. I know two sides of the triangle and then the angle between. It's a 20-degree angle. And I'm using this formula that I've got circled here. 1/2 times 2 is 1, times 5 is 5, times sine of 20 degrees. 5 times sine of 20 degrees is 1.71. Okay, and of course make sure that you're in degree measure. We've been in degree measure for nearly all the problems here in this whole chapter. Okay, so there's a couple of problems where you're going to be using that formula. Heron's formula is another way to compute area of a triangle. Okay, and here's Heron's formula. The area is the square root of s times s minus a times s minus b times s minus c, where s is 1/2 times a plus b plus c. Okay, now suppose that you have a triangle where you know all three sides. It doesn't matter what kind of triangle it is. It could be a right triangle or an acute triangle or obtuse or whatever. Doesn't matter. If you know all three sides, you can compute the area of that triangle by using Heron's formula. I've got a proof of Heron's formula, which you can look at if you want. I've started off with the area of the triangle, the alternate version that I had circled right here. And then I'm using my Pythagorean identity along with the law of cosines. And then after that, it's just a lot of simplifying and using some algebraic manipulation. Okay, so you can look at that over if you'd like. Here's the formula that we are going to be using. And so I've got an example. Suppose that we have a triangle with these three sides known, and I want to know the area of the triangle. Well, of course, 1/2 base times height doesn't apply, right, because I don't know the height of this triangle at all, and of course it's not a right triangle or anything like that. So I would want to be using Heron's formula. I want to first get s. S is 1/2 times the quantity a plus b plus c. So if I take 8 plus 5 plus 4, that's 17. Half of 17 would be 17 halves. And so then I'd be plugging in my information here into the formula. So let me go ahead and do that. I want to take the square root of 17 halves times 17 halves minus a. That first number was 8. Times 17, hey, whoops, I forgot a parentheses there. Oh, no, I'm okay. Sorry about that. Okay, so 17 halves minus, use 4 is the next one there. And then times 17 halves minus 5. And then close up the parentheses for the underneath the radical. And 8.18 is what I'm getting if you go nearest 2 digits. Okay, and so that would be the area of this triangle here. That's really all there is in the section. In the notes on Blackboard, I had another example that you can look at this if you want. This was just going to be if we had some extra time, kind of a neat problem with area, and so we're going to go ahead and omit that and call it good at this point. So the homework is on page 556 there in section 8.4, and we are now done with chapter 8.